And just to kind of talk about what we're going to be speaking about today and going through is not a step-by-step for how to use platforms to make illustrations. There are a variety of different illustrating platforms online that you can access. And there's also accompanying YouTube videos that are very detailed and very useful for things that we're going to be talking about today. So we're mainly focusing on different graphic design principles and communication strategies. And although I'm going to be focusing on these things, if you have any questions about Designs That Sell, which is the scientific illustrations company here, or myself or my journey, I'd be happy to answer them at the end of the presentation. So I'm going to start off by telling you guys a little bit about myself and Designs That Sell. Oops. So currently, right now, I am a PhD student in Dr. Jeanette Boudreau's lab at Dalhousie University, but I have been in a few labs throughout my training, and my path to where I am in my career right now has not been as linear as some. So I started off doing my undergrad degree at the University of Guelph, and then I went to Queen's University where I did my master's in biochemistry and cellular biology, and in the summer between that and starting medical school, I founded Designs That Sell, which was initially started as a way for me to provide my freelance scientific illustration services. Quickly from there, it grew to having a very solid clientele base of repeat academics and medical experts that require scientific illustrations, and kind of took off from there, which is fantastic and really exciting. But as I went into medical school, I found that I didn't really have as much time to be actually taking on active projects, and ended up taking more of a backseat role for the past few years. And so you're probably wondering how I did med school and then a PhD. I actually didn't finish medical school. I was in medical school for about a year and a half, found that I was really missing some of the freedoms that come with being in a research lab and being able to kind of find different interests and participate in SciComm and take active projects from the clients that were coming in. So as of January, I am just starting out my PhD. Like I had mentioned, and I found that I do have a lot more time, and I've been really happy with some of the new initiatives that we've been starting with Designs That Sell. So currently, we have about 8 core team members across Canada and the US. Kristen is in New York here, as you can see. And these are all graduate trained illustrators that have some kind of focus in graphic design, either a background of a Bachelor of Arts that they did, or course kind of training in infographics and things like that. So everyone's expertise is a little bit different, and the path and education that they took is also different. We have quite a few cancer researchers, but we have some experts in things like plant biology and engineering as well. So we cover quite a broad range of topics, although you'll notice that if you visit our website, most of our illustrations are with a biological focus, and that's just kind of the nature of the clientele that we've picked up so far. So I'd be happy to answer any questions about Designs That Sell. I'm just going to briefly talk about what services we provide as well, so you guys kind of know where my expertise lies. And so we mainly do custom illustrations, and these can be for a variety of things, including publications or education material. We've done a lot of coursework and online course development, which is particularly relevant in these times. We've also helped students with thesis projects, so being able to have a nice branded thesis with really good figures. We've also done a lot of logos and branding with a SciComm focus, so some medical technology companies, as well as some conferences and those businesses along that SciComm line. And in line with SciComm, we also do content creation for a variety of companies, nonprofit as well as governmental, for content creation for their social medias, for scientific strategies, as well as infographics. And most recently, which we're really excited to be able to offer, is consulting, which includes 48-hour abstract and poster review, where we have basically some, and this is graphical abstracts as well, where we have somebody review your poster for kind of the main things, honestly, that we're going to be talking about in this presentation. So I'm hoping that you guys will be able to do that yourselves and not have to use our services. But also we review grant figures to make sure that they're as effective as they can be, in presentations as well. And we're also getting into the research area. This entire workshop, while I'm presenting it, was not just me in terms of the development. It was a variety of people, Designs That Sell team members, as well as some other scientists and artists who contributed to putting together a paper for the student BMJ, which is going to be coming out soon, which will highlight a lot of the same concepts that I'm talking about today. So just to give you guys a brief overview of what we're going to be looking at and focusing on, I'm going to give you guys some background about why visual communication is so important and what it can be used for and who can use it. And then we're going to get into 8 steps for creating an effective scientific illustration, or protocol, is what I like to use as a term for scientists, because this is how we think about things, and we like to think about things very logically and having a strategy when approaching whatever that challenge is. And in this case, for a lot of us, that challenge is creating scientific illustrations. And throughout the presentation, I'll be using a variety of illustrations, some of which are from the Designs That Sell team. So as you can see here on the right, this is an illustration that Naomi did, and it was recently featured in Radiographics. So this was a illustration that was kind of a more educational focus, and that's another thing that we do as well for anatomical processes that don't necessarily need to be very anatomically accurate, but need to be able to, you know, for example, in this picture, show different blood vessels and the anatomical location relative to other organs. And so you're going to notice a lot of those illustrations, and I'll try to mention who's illustrated them from my team. That way, if you're interested in working with them, you can reach out to them, and they also would be happy to answer questions I know about any kind of approach that they use as well. So where can you use scientific illustrations? And there's really not really a limit for SciComm, what I found, but some examples where you've probably seen illustrations are poster presentations, oral presentations, publications, graphical abstracts, which is now becoming its own field in itself. And there's been some, albeit limited, research done on how graphical abstracts impacts visibility and readership, with some interesting findings there. But some journals, interestingly, are actually requesting that you develop graphical abstracts when submitting manuscripts. So this might be something that you consider when thinking about putting a manuscript together. And we can talk about how to do that as well. All the points that we're going to be talking about later, the 8 steps, can apply to a publication, graphical abstract, or any of these. Donors and the general public, so a lot of people are working with funders and trying to get their science communicated to lay audiences. So using visuals is a really great way to increase accessibility for people who may not understand in terms of the actual written communication, some of the technical jargon that we like to use, but they are a lot more familiar with graphical representations, or if they have visuals to accompany you explaining something to them, might be a lot easier for them to digest and understand. In addition to that, as I mentioned, theses is always good places, yeah, always good places to be able to accompany with some custom illustrations as well. Education grants to patients. So we do work with clinicians quite a bit, and visual illustrations are really handy to be able to explain processes. So for researchers, if you're involved in clinical trials in any way, developing informed consent forms, or kind of trying to find a way to communicate what your clinical trial is to a patient, using visuals can again help with that accessibility. Friends or family, so a lot of you probably are trying to explain to your family, you know, that might not be scientists what you're doing, and it's really nice to have some visuals to be able to walk them through the process, because you want them to be as excited about the science as you are. And social media as well, with the SciComm era that is really booming and can really help share the visibility of your research and the reach of your research, and include other people, which has its own benefits in a variety of reasons, including, you know, talking with people in your field from different areas that you might not have had a chance to speak to at a conference. So those are just some examples, but definitely not an exhaustive list. And I'm sure that all of you are now thinking, okay, where can I incorporate visual communication into my research? And I'm sure you'll have other ideas than what I've listed here. When I started Designs That Sell, I was really curious about understanding the need in the immediate community I was in. So I did this at Queen's University. I sent out kind of like a marketing research focused questionnaire to the researchers, the PIs, and the students at Queen's University and the Cancer Research Institute. And I'm just highlighting a few of the questions here that I found really interesting in terms of their responses. So first of all, I asked them if they found communicating their research with figures or graphics was helpful. And unsurprisingly, 100% said yes, which was great. And then I also asked them if they had created graphics, schematics, or illustrations. And here you can see that the vast majority of them had. The ones who hadn't had likely been earlier stage graduate students who hadn't had that chance to really communicate their research. I also asked if people had reached out to a medical illustrator or scientific illustrator to help create figures, and I was surprised that a large number had. just based off of, I suppose, my colleagues that I was talking to directly, they hadn't really looked into reaching out to anybody to get that support. And obviously at this time I had also looked into what resources there were for scientists trying to create figures, and I found out that there really wasn't a lot. And we're trying to grow into this space to be able to empower you guys to be able to sit down, create an effective illustration, and really just improve science communication across the field. Another thing that was really interesting off of this small marketing study that we did was the amount of time that students and PIs put into actually creating their illustrations. So the average ended up being about 5 hours, but I had some responses, as you can see by this graph, that would spend 30 hours working on one illustration. And so obviously this is not the most efficient way to do it. And if you're a perfectionist, there can be some things that you might spend some more time on, but it definitely should not take about 30 hours. And so again, like this was developed to help make it into a kind of ordered and logical strategy to help you guys be able to see what to focus on and how to basically enhance the effectiveness without having to spend a lot more time into developing the illustrations. And this is just a quote that I really liked from kind of the open end part of the survey, where a student talks about the value of it. So creating and generating high quality images that are concise not only helps to convey your scientific message, but it also creates interest in your work, which is what anyone doing research would want. And what's the point of it? So what does visual communication do? Although I kind of touched on these points, I'm just going to reiterate some of them again. First of all, visual illustrations are more memorable. If you look into the literature surrounding the psychology of how people interact with verbal communication versus visual communication, it is clear that using visuals can help people recall and remember your research or whatever you're trying to get across. So this might be a publication that you put out that someone can't quite remember the name, but they can remember the illustration. It might be a poster that they pass by and they remember your research kind of, and it's that illustration that really brings them back. They remember that graph or that picture that you had on your poster. It also attracts readers to your research. So when I'm talking with a lot of undergraduate students about how to frame and create more accessible science, a lot of them say that something that deters them from reading articles is the language. And so it's challenging for them to sit there and read through 5 pages of dense jargon, but being able to have a figure that accompanies it and almost walks them through that process, the methods or the results, can really help them be, attracted to pick that article over another. It also increases visibility of your research online, and I think this is really relevant in the current time when we have about 100 or more publications coming out every week in your field. It's really hard to stand out and get your research to speak for itself, and illustrations are a great way to do that. You can also clarify and fine-tune ideas. So this specifically is about saving word counts. Whether you're writing a grant or you're working on your own scholarship applications and you can accompany them with figures, wherever you can do that, that replaces texts and you're able to kind of write your proposal or write your objectives and reference that illustration will just save you that many words that you'll have to be constantly inputting. So for example, if you're explaining a method and it's challenging to kind of walk through all the steps, it might be good to just put in an illustration that explains that process, with little boxes of descriptions, and just reference that illustration when you're talking about that specific method in your scholarship or your grant. And again, accessibility is really important. So thinking about who's going to be able to understand your science. And one thing that I do want to focus on is Twitter. So this is an illustration that we did last year, and it was tweeted. And essentially, I'm showing this to emphasize this one social media platform that is up and coming, if not already existing, in a space that really encourages and promotes science communication within people that follow, for example, this is a journal, so people who follow that journal directly or people who network and follow other graduate students. There's a whole community of academic chatter, PhD chatter that is fantastic to be able to engage with and ask questions and learn from. I've made some really good connections on Twitter, and I definitely encourage you all to check it out. And visual communication specifically really enhances Twitter use. So for example, if you're tweeting something without an image versus an image, some studies have shown that it can increase up to 18% more clicks, which essentially means someone's engaging with that tweet. 89% more favorites, so that'll show up both on the person who liked it or favorited it, as well as anyone who follows that individual, and 150% more retweets, which is basically just going to exponentially increase your reach and the people who are seeing that illustration and then are going to be curious and then follow that link to that publication and hopefully read it. And before we get into these 8 steps, I really like this quote by an inspirational scientist who was definitely ahead of her time, Anne Rowe. So nothing in science has any value to society if it's not communicated. And Anne Rowe was a very interesting psychologist and scientist who researched specifically about creativity in scientists, actually, and she did a lot of work through a feminist lens. So if you're curious about some good inspirational scientists, you should look her up. But this also resonates with me and really resonates with the whole kind of mission that Designs That Sell was founded on, which is that the point of doing science is not to keep it with yourself, but it's to share it so that you can have an impact. And that's why I got involved in research and why I'm so passionate about it. And I'm sure a lot of you feel the same as well. But you might not feel so great when thinking about how to put a scientific illustration or figure together. When I was talking with those students at Queen's University, I found that the biggest challenge or the biggest roadblock they faced was where to start. And so we're going to start off with our 8 steps and we're going to go through it. And hopefully the next time you sit down to start an illustration or a figure, you don't feel like this Lord of the Rings reference. And so one thing that I do want to focus on through these 8 steps is that beautiful does not equal effective. So having a lovely, visually attractive illustration is awesome if you have the time and the skill to put into it, but that doesn't mean that it's going to be an effective illustration. And there are definitely differences between them. Although ideally you want to have both, the focus really here is about being effective. And so it's about looking at those graphic design principles that enhance communication. We're not thinking about the graphic design principles to make it look pretty. And so that's what we're focusing on here. And the things that we're going to highlight and show with illustrations is not necessarily, you know, that they're the most beautiful illustrations, but they're strategies that you can use to make them the most effective, meaning they communicate what you're trying to get across through that illustration most effectively. And so we're going to start off, this is the first step that you have to take, and arguably the most important one, which is understanding your target audience. And so these first 3 steps that I'm going to talk about have to be done before you do any kind of layout planning or even before you sit down on a platform. So you should understand who you're making your illustration for and who you're trying to communicate it to. And so things that you have to consider when, for example, making a presentation is who is going to be in the audience. Are you going to be speaking with a class of grad students that have the same knowledge as you because you all took the same class and have listened to the same lessons? Or are you going to be presenting at a conference where the audience might be made up of people from a variety of different fields? This is really important as well for publication. So thinking about who's going to be reading your article. If you're publishing in a disease-specific journal, maybe there's some specifics that you can leave out that you can assume that your readership will understand. Or you publishing in a journal with a wider audience, and so you kind of have to explain some of the nuances in that field that other people might not be as familiar with. And so when creating this, there's also really a flexibility that should be thought about from the get-go, which is both being able to add additional content to your illustration as well as be able to pull back and simplify. And so what I mean by this is when you're setting up your target audience, have that frame of mind, but don't restrict yourself so that if you wanted to go in and, for example, you made a schematic for a presentation, but wanted to publish that same schematic, maybe you want to go in and provide more detail about a specific molecular process and a larger kind of physiologic representation. And so being able to leave that opportunity to add additional content is really important, and as well as simplifying. So thinking about, you know, components that might not be necessary if you know that if you know that that component is not key to what you're trying to get across to your specific audience. And so to illustrate this concept without my intentional pun there, I'm giving an example of basically the basic textbook biology illustration of a cell. So when you're introducing a cell to somebody who is not familiar with science, you want to show the different components of the cell, kind of give them an example of a 3D structure, but you might not want to overwhelm them about all the specifics. Now, within the same level of understanding, if you showed somebody this illustration, they would be put off by it immediately because amount of content that's there and the detail and the complexity of the actual illustration itself. And so when a lot of us are looking at this with the science background, we can clearly understand some of the key differences. Like we look at the membranes between a plant cell and a human cell or animal cell, and we can see, okay, yeah, we understand that plant cell structure is different. But for somebody without that understanding, looking at this illustration can be very overwhelming and confusing. And so that's just a simple way to show that having that different audience being your main focus will really inform the rest of the decisions that you make through this 8-step process. And so this is just an example that I also wanted to show. It's an illustration that we did for a review article last year. And this is an example of what I was talking about when I was talking about adding information or putting in molecular processes in a blowout fashion. So for example, I'm not sure you guys can see my mouse here. Hopefully you can. You can see kind of this process. So within the tumor cells that are in this lung metastasis, for example, we can then go in and look at the molecular processes. But for somebody who's more kind of on the introductory stage of cancer biology, maybe they look at that background image first and try to understand what that process is there before they go into the molecular specifics. And again, I have it highlighted here. Make sure that this decision is made first and that you have your target audience in mind for the rest of your decisions. And I will probably repeat that a lot of times throughout this presentation, but it's because it's very important. So step 2 is identifying an illustration platform. Like I said, this isn't a step-by-step how-to on Illustrator or any of these platforms, but I will bring them up and say that the choices that you make and what you pick here is going to have an effect on what you're able to do with your figures. And so what I found mostly with scientists, they're working within these 3 platforms. PowerPoint for most of the basic scientists, I would say, focus on this. Canva for a lot of the clinical sciences when they want to make posters or infographics. And then for people with either, you know, a really keen interest in design or that want to torture themselves, they will venture into Adobe Illustrator and Photoshop. And so when thinking about these different strategies, you want to think about how much time you're going to be sitting there and trying to figure out how to work a platform. And really, is it going to be worth it in the end for your time and everyone else's time that basically you're going to be, you know, having to manipulate or adjust the illustration, because chances are what you like and how you like it set up, your PI or your supervisor might not, or another student might point out something. So having to have a platform that you're comfortable with and that you are able to adjust is a lot more important than having like the most advanced platform that you possibly can. And this is just a meme explaining some of the, I would say, attitudes that I've heard of students trying to figure out Adobe Suite, because they think that this is like the only way to make an effective illustration, which is not true. So something to keep in mind also when you're thinking about what platform would fit what your goal is best, it's good to think about how user-friendly they are, but also how customizable they are. So if you are looking for something that you know, you want a specific organ with a specific process and you can't find any clip art or illustrations, which I'll give you some resources later on for some medical clip art. If you can't find those, then maybe you do need to go to Illustrator and you can make that customizable. But again, that gets to the level of having a very high technical skill and complexity. So it's just whatever you do choose, make sure that you're comfortable with it and that you're able to navigate through it easily. And again, there are tons of YouTube platforms or videos rather that are explain the step-by-step for the different skills and how to use the platforms as well. Canva, for those of you who don't know, is a drag and drop. So it's an online platform for creating illustrations or graphics, and they have a variety of things that are free. They also have a kind of pay-as-you-go service for different illustrations and things, but I find that their free version is very accessible and very useful for, again, that clinical side of research, or maybe even if you're trying to explain a schematic where you're using human samples and you're explaining that. So yeah, I would check it out if you haven't used it before, and it's definitely a really good resource for quick, visually appealing, and also has all the same graphic design options as something like PowerPoint as well, but with that drag and drop feature. So once you have figured out your audience and you've picked the platform that you're going to work with, you have to pick the most important points that you want to communicate. So when I'm talking with somebody who is either requesting an illustration or trying to figure out what to put in their illustration, I set a maximum of 3 priorities. And so what I tell people to think about these is as their three main result sections. So if you're writing a manuscript, if you could pick three things that somebody was going to come away with from it, what would those three things be? And so I want people to be able to do the same thing for their illustrations. And the reason for this is that if you have three main points and you make sure that those are included, and that's what you do as a plan as your first go on the illustration, there's always opportunity to add more. It's the same as kind of any scientific paper. You have the opportunity to add more, but you need to make sure that your key message and your key communication strategies are in there from step one. So 3 different priorities that you select, and you can have some subpoints because some people do get angry about having to limit the ideas that they want to convey through their illustration. So the example that I'm going to give for this strategy or this step is the central dogma of molecular biology. So for different visualization strategies, there are different ways that you can highlight something like a process. But for example, if we look at this illustration, there's not really anything that's standing out from another. All the fonts use the same. As you can see, this was developed in 1996 when I was 2 years old. So obviously not the probably most updated illustration, may have been good at the time, but today it would not pass as something that is communicating in an effective way. I'm also going to show another illustration that has all the same content as the previous one, but again, we have some different areas of focus. So perhaps this scientist was trying to highlight the function or places where some of the enzymes are involved. Again, it's not really clear where the processes are, and the message and the point of the central dogma is lost. This last illustration I found online actually through a textbook, and I really liked it for a few reasons. One of which is that you can really see the different components of the central dogma. So those 3 things, let's say DNA replication, transcription, and translation, that are highlighted and isolated as a process here on the right, with arrows that are all similar again, and then also the objects are separated. So you can understand that 1, we have the object or the entity, which is the DNA, RNA, and the protein, and then 2, we have those processes, and this is really highlighting those 3 key points. And they've even included, maybe that was their subpoint, that we wanted to show that, you know, we have different bases that are involved and we end up with different amino acids. So legends are a really great way to kind of add those subpoints in where they can provide additional context, but you don't necessarily need them to understand what the illustration is trying to convey. So moving on to step 4, this is really where the graphic design principles get a little bit heavy. And so we've tried to, as part of putting together this workshop or presentation, put them into concepts that are digestible. And so we came out with the ABCs of layout and composition. And we're going to be walking you through these. And again, this is at the stage where now you've got your first 3 steps, you know what you're communicating, you know who your audience is, and you know how you're going to be creating your illustration. So now you have to start thinking about where you're going to put things and how the layout works. And so these are things that are based in graphic design principles, but we've made them so that they're actionable for scientists who don't have hours to spend on fine-tuning things very specifically. The first of which is alignment. So you've probably noticed that when you're playing around with things on PowerPoint or Illustrator, if you're savvy in that, that you have these points that come up when things are aligned. And you might wonder why they do that for every single thing. It's because it's extremely important for communication and it's an extremely important design principle. So this is basically keeping things within the same line or plane. And again, those 3 platforms all have their own individual alignment tools. Pretty much any kind of graphic design or illustration platform will have that. And to illustrate this example, I'm using the process of differentiating blood cells. So what you can see here is pretty much a mashup of different cells and probably an illustration that we're pretty familiar with at this point. So taking a look at this, there's a few things in terms of alignment that you'll probably notice right off the bat that's a little bit off, but generally you might still get the idea of what they're trying to communicate. And I want you to try to keep this image in your head as we go to the next one, which is the exact same information presented in a different way, which is aligned. And so what you can see is that your eye, in terms of where you're looking through this illustration, will be able to follow along planes instead of follow along the path. And so you get a better picture of the fact that you're starting off with one thing and ending off with these many differentiated cells. And this may not seem so important, but when you have other components to an illustration that is compounded on to something that's not aligned, it can get very confusing for people in terms of where they're going to look, what components are grouped together. So although this is a simple example, it's definitely an important thing to consider. B is for balance. So balance, in our case here, what we're talking about is limiting the space that you're using and organizing it in a way that, you might potentially need some white or negative space. So white or negative space is basically space that has nothing in the illustration. And you might be wondering how space can help communicate something more effectively. I will just show you a simple example using text, which is kind of the most classic example, I would say, where you see white space being used. So as you can see on the left, there's no white space. In the middle, you have this basic use of white space, so paragraphs making it a little bit more digestible. And then on the right, you have advanced use of white space, or basically somebody who knows how to separate things so that the reader can be caught to different things depending on where their attention goes. But again, they see a logical flow from top to bottom. So to illustrate this point, we have the process of photosynthesis here. So this illustration is pretty simple in terms of what it's trying to communicate, which is how photosynthesis works. But things that I want you to notice are the space that they're using in between different objects. So for example, the sunlight arrow is almost touching this carbon dioxide arrow, which, while just looking at this process we're familiar with, if it was something that we weren't familiar with and something that was more complicated, it would be challenging for us to separate those two concepts differently. Additionally, I'm not sure why the sunflower is the exact same shape as the sun, but again, that's their own personal design preference. And so I want you to keep this in your mind right now, and I'm going to flip to the next one, which is going to be showing the exact same information. If not, they've included a little bit more detail on a few things, but using negative space. So you can see, looking at something like this, where exactly the same components, exactly the same things that are focused on. Even here, they're showing, again, the carbon dioxide being oxidized in here, as well as the chlorophyll specifically within the plant cell in a basic way. And this is a lot more digestible because they have used white space to separate their different concepts. And so white space can be really useful if you're looking for strategies on how to effectively use white space. I would say that using something that is consistent, so if you're keeping, let's say, 2 text boxes separate, just making sure that that space is maintained throughout. And if you're ever too kind of confused about if your illustration needs white space or if it can kind of be closer in proximity, you can simply test out the accessibility of it by removing components, putting components back in, and then having them side by side. So that's a really easy way to see how busy your illustration is. Contrast is our C. So contrast is really important for highlighting those key points that you want someone to take away. So for highlighting and contrast, there are a variety of different strategies that you can use, including using different fonts. Fonts are a really great strategy for doing that. So whether that's, how we have our custom designs that cell font here, that's very loud and very playful, that's definitely a strategy. You can also use shapes. So I'm sure as scientists, many of you has also done this on a graph or on a chart, and you've boxed in an area where you want people to focus on. You can do the same thing with scientific illustrations. And as long as you're keeping it consistent, which is where our next letter is going to be, it will help with the illustration, and it will help people differentiate the important points from the background points. So this is just an example. Again, I'm using simple scientific concepts. This is our carbon cycle. So as you're kind of looking at the different components here, it's not immediately obvious what is a component and what is a process, although they've used color to differentiate them. So this is an example of a use of contrast that's not very effective. And then again, comparing it to a more effective strategy, you can see here that now they've taken those objects, those key players, and they've boxed them into an actual box. And so what you can quickly look at this illustration and pick up is that you have these different players and you have processes between them, and those two things are very different. And again, it's not about being the most pretty or the most advanced illustration, it's about being effective. And so contrast can be really useful when you're talking about labeling processes that you want people to focus on, or labeling objects. So if you're trying to get across a relationship between 2 objects and those are the only 2 things there, then maybe you label them at the top, you box it in, you bold the font so that it can look separate from the rest of your labels. And color can be a good use for contrast if it's done properly. I wouldn't recommend using a very dark green and a black. I would recommend using something like red and a black or something separate that can really make it stand out. Okay, so D is duplicate. So this is what I was talking about with consistency. So you want to make sure that you're maintaining the same look and style in your illustration as much as you can. And so this includes color scheme. So picking a color scheme we'll talk about in a little bit, but keeping it consistent through your illustration, the typography, the methods of contrast, and the methods of how you're making things in a logical order. So keeping it consistent means that people have to spend less time digesting what your illustration is and more time being able to focus on the science. And so an example that I would like to give for this is the cell cycle. So as you can see here, this is a beautiful illustration. I found it online. I'm not too sure who to give credit for it, but it's lovely. Has a lot of different colors. However, it's really confusing for the cell cycle. It's actually one of the more confusing illustrations that I've seen. So what you can see here is that they haven't kept many things consistent, including how they've illustrated the cell, how they've illustrated the DNA within the cell, the descriptions in terms of their length, in terms of the color that they use and the font. So comparing this illustration, which is beautiful, to this illustration, which somebody would look at and say, yeah, it's not as visually attractive, it is, though, a lot more effective, and that's because they've kept things consistent. So with the font that they use to label the different cell cycle phase, with the descriptions underneath, with the color consistency that they kept within the chromosomes and the cell themselves, so you understand what is going on. So we're not focused on trying to figure out what's happening with the illustration, we're focused on what's happening inside the cell, and as a result, what's happening with the cell cycle, which is the point of this figure. And the last thing of our ABCs is efficiency. So this is talking about how you go about laying out and organizing what you're putting into your illustration. So the idea of laying out something might be that you use a piece of paper or PowerPoint or an iPad to basically illustrate out the different components. You can use circles or triangles to represent different things. So let's say we're doing a relationship between cell A and cell B. Maybe you have a circle and a square to show the difference there, just to be able to kind of use it as a placeholder for now. And so this process is basically being able to tell the person who is looking at your illustration where to start and where to go next. So there are a variety of strategies on how to do that. With graphic design, what's most commonly used, and I would say most effective, is starting at the top left and going to the top right. So you've probably thought about this when presenting posters, or even a presentation. You start from the top left, you move to the bottom right. And so this is similar with your illustrations. Doing it differently can be effective in specific circumstances where you're very advanced on visual communication. But if you're not very sure about how to organize your illustrations, it's really good to just keep that as kind of a rule of thumb and refer back to that. So different ways you can tell somebody where to start and where to go. Arrows are great. So they're fantastic when you use them properly. Overusing them can make them very complicated and complex. So I would say anything where you're using over 10 arrows is probably not the most effective, and you should look at different strategies for that. Another strategy might be numbering. So if you're trying to get somebody to follow a process and there are different interrelationships between them, then numbering them so that people can easily go from 1, 2, or 3 or ABC can be an effective strategy. In addition to that, you can use color. So kind of like the cell cycle illustration that I was showing you earlier, if you're using shades of color, that can also direct a viewer, but that's, again, like more of an advanced graphic design strategy, and I probably wouldn't recommend it if you're just kind of starting out in this route. And then, of course, white space to separate individual processes. If someone has all the information clumped into one area, it's really hard to break that apart and figure out where that person's going to go through that illustration. Being able to separate those components can make something as complicated and busy to something that's very clear and easy to understand. So efficiency is a great tool that you should plan to use and think about. And to show this example, I've gotten a few different illustrations here. This is a disaster that I found when I Googled overuse of arrows, and you'd be surprised how many, I would say, ideas and hypotheses I see for grants that look like this, which kind of reminds me, or if I was to visualize what like a scientist's mind would look like, this is probably what I would visualize, but it's not the most effective for trying to communicate. So two examples that I have to show this are from a textbook talking about phagocytosis, endocytosis, and exocytosis. And what you can see here is that there are a lot of different components, and they've kind of included both arrows and numbering and a variety of graphic design principles, but they've done it in a way that's really confusing for the viewer. And so a better strategy than having, these processes that start out A, B, and then end up somehow in the cell with C and D is better to keep the processes linear if you can and communicate the same amount of information. So from the same textbook, which I thought was pretty funny, I pulled another illustration, which is the exact same thing that is being shown, but endocytosis and exocytosis. And as you can see, this is a linear process. So they've actually started here on the bottom left with their numbering, moved up, moved across the illustration, outside through exocytosis, and then inside through endocytosis. And so you can see just between these two illustrations, which have the same content, but approach it differently in terms of how they would like the viewer to walk through it, can really have an impact on how easily somebody can look at it and understand what you're trying to get across with your illustration. And so step 5, this is my favorite step, and this is picking an appropriate color scheme. So colors are a really, really useful tool when they're used properly. If you can't use color, for example, in publications where they charge for color and you don't want to pay for that, then shading works really well as well. With color, generally keeping things as kind of status quo or what they're understood is favorable. So when you can, keeping things physiologically sensible, like not having a hot pink liver, is probably a good idea for people to be able to look at it. And again, visually, they're be able to process that a lot easier than something that's abnormal from what they're used to looking at. And with that, there's also some biases that can be introduced. So this is really important when communicating science, because somebody can definitely take an illustration off of, let's say, Twitter and interpret something completely different from what you were trying to say. And obviously in the age of social media, where there's a lot of mass confusion about specific topics, this is something that I have been seeing again and again on Twitter, specifically with COVID, is people taking an illustration or graphic or some kind of a visualization map, and due to color, they've misinterpreted what that actually was originally stated as. So here are just some examples, red being a positive charge, blue being negative, green meaning increase, red decrease, same with like activation or suppression. So these are all things you can probably think about and keep in mind when you're doing your illustrations in terms of use of color. Also an important consideration is accessibility. So obviously there are people who are colorblind who are not going to be able to interact with your illustrations in the same way that somebody who is able to see color effectively. And so there are some things that you can do to avoid being able to make it so that anyone who's looking at your illustration who is colorblind in the more common ways would be able to still differentiate the different components. So I've included some examples of colors that you should avoid overlapping. However, you can overlap colors if you're using different shapes or different patterns. So using things that are kind of like a next layer to color, just allow it for people who may not be able to see that color. So for example, if you're doing a graph and you have different bars that you are colored differently, adding a pattern is just kind of that extra layer of a different technique to differentiate the different components. So this is an example that I have of a blood vessel, which isn't immediately, I would say, obvious to me from looking at this, because again, it is hot pink and peach and not really what you would imagine. And so to understand this illustration, you can't understand it by just looking at it. You would have to actually go into the written text of the illustration, which kind of defeats the purpose of visual communication. This is something we're a lot more familiar with, which is an example of how color can really have a powerful impact. The left and the right of this illustration is exactly the same, other than the color. And so the labels, while supplemental, are not key for the actual communication piece here. So this is just one example. There are several other examples, and you'll probably catch them now that you're looking out for that. And I've also provided some color codes here, which you can use. So this is the Designs That Sell color palette, if you like how we have our slides and our website and things like that. And then on the left, this is kind of the starter kit for what you need for a color scheme, which is highlight colors, a base color, as well as something that can be used to, emphasize different components. So for example, if you know that you have 3 main components that you want somebody to take away and 2 different processes, then perhaps you put those different components in one color and you differentiate the 2 processes in a highlight or an accent color. With colors and coming up with color, schemes, sometimes it's really challenging to figure out what looks good. And so I've included a few different resources for you guys to be able to use. And again, this is being recorded, so you can watch this again, and I'll also provide my slides for these resources. So this is one resource, Coolers, which is really great for generating color schemes. It kind of pops up different ones and you can lock certain ones in place until you find something that you're happy with. There are also Color Hunt, which is basically for graphic designers, preset color schemes that you can pull off and interact with. And next, and we're almost done, we have 2 more steps, is typography or font. So some people might not think about font so much, but it actually does have a large impact on how your illustration or your mode of scientific communication is perceived. So there's 2 main categories, the first one being sans serif and the second being serif. Sans serif basically means that the edges are not ticked off by a little mark. And this comes off technically as most modern and approachable. So it's kind of informal if you're trying to label it as a characteristic versus serif, where you have these small horizontal lines and it actually adds a feel of more classical and traditional. And to prove the point that font can have a big impact on how things are perceived, I pulled off 2 posters from the online web to kind of give an example of how it can have such a strong impact on if somebody, let's say, approaches your poster or not. On the left here, you have the font that's a little bit more classic, a little bit more professional, and on the right, you have something that's more modern and more approachable. And so depending on what your goal is, and again, who your audience is, you might have to go one way or another. And if you're not sure for posters or for anything that you're trying to communicate with the general public or SciComm or trying to get outside your field, it's really, I would say, preferential for people to use fonts that are more approachable and more modern. And essentially, when you're going to pick your font, picking something that is clear, readable, and fits the target audience is the most important. And again, I want to provide resources for getting some fonts. And if you want to get creative with it, Google has 977 fonts for free at googlefonts.com. So you can download any of the fonts that you might find helpful. And although they might not have everything that you'll see online, if you Google fonts that are similar, you can find ones that may appeal to you specifically. And I would say this is a really good place in science to be creative and have fun. Because fonts are fonts, and as long as it's readable and understandable, it functions the same, whether it's a modern font or a very classic font. And step 7 is labels. So we talked about arrows a little bit, but we haven't talked about labeling yet. So being conscious of both over and under labeling is really important. So again, if you're talking about something physiologically representative that people in your field will understand, maybe you don't need to label it. If you're going outside your field where people might not be as comfortable with certain aspects, or if you're trying to communicate with the public and you have, let's say, like a pipette or something like that, then you might need to label that and explain what it is and how it's used. In terms of orientation, specifically when referencing layout, things that are important to consider are the actual orientation of the labels being horizontal, vertical, or 45 degrees. These are graphic design principles. Going anywhere outside of that or being inconsistent between them allows your kind of your visual gaze to be distracted from what you're trying to understand. Another thing is keeping all the lines the same thickness unless you're trying to emphasize a specific point. And again, if you're labeling things, you should try as much to be as consistent in aligning your labels as possible. And last but not least, the most important point about lines is that they should not cross. If you absolutely must have lines that overlap on an illustration, be sure that you use some kind of differentiating factor, either the thickness of the line or you can use color. And the last step is putting in your actual figures and illustrations. So whether these are things that you're able to do yourself, or if you're using clip art or different symbols to represent different components of your illustration, you want to make sure that they're as simple as possible. So what is the minimum amount of information that I need to put in this picture or this visual representation or graphic for somebody to understand what I'm saying? If I am trying to do a project on ovarian cancer and I want to have a patient, then I'm going to focus on a female patient, and that's going to be my graphic. If I want to talk about a general population, maybe I put a mix of people, but as simple as you can get it is generally the best rule of thumb. You don't want people having to try to decipher your text at the same time as your labels, at the same time as your actual communication strategy that you've put in the work to actually communicate. So I want to give some resources on coming up with illustrations and using some really great online resources. This is my personal favorite because I love their style, and I actually use it for quite a few inspirations for some of the things that I work on because I think it's really bright, colorful, and fun. And Serbia has a variety of different sets that you can use, download copyright free, including anatomy, biology, some medical specialties, as well as lab equipment. So I highly recommend that you check this out. I showed it to people in the Boudreaux lab, and all our presentations, surely enough, became very similar very quickly. But they're great, and they're very clear and very visually appealing too, which is always a bonus. There's also some different resources. This is the Public Health Image Library. If you're looking for photos and illustrations of physiologically or biologically relevant, species or specific bacteria, then this is a really good place to go. So I recommend this for any kind of more specific illustrations. There's also this other free image database, which again has a variety of anatomy, biology, and labware in a variety of colors that you can change and pick. And it is, again, free from copyright and able to be used, which is fantastic for students. So that brings us to the end of the 8 steps. So just to kind of overview and repeat them again. So understanding your audience, really, really important, and should frame the rest of your steps. Steps 2 and 3 are again done before you start your illustration. So figuring out how you're going to make it and picking your most important points to communicate. Steps 4 to 8 are really where the graphic design principles come in. So thinking about things like the ABCs of the layout and composition, picking an appropriate color scheme, choosing which font or typography you're going to go with, setting up your labels, and then lastly, putting in and replacing those placeholders with your shapes, illustrations, or graphics, whatever you end up using for your specific illustration. And so this comes to the end of my presentation. I would like to thank all of you for being here and listening to me for the past hour. And I'd also like to really give a shout out to the co-authors of this workshop and the article that we'll be putting out soon in the BMJ for the 8 steps, and that's Natasha, Cheryl, and Stephanie, as well as the other Designs that Sell team members that help supported this process. I also have to say thank you to Dr. Boudreaux, because she supports all my extracurricular activities, which are definitely not mandatory for graduate school, but she supports them and allows me the space to be creative and have fun and illustrate, which I'm really thankful for. And I'd be happy to take any questions, again, about illustrations or about platforms or about my journey and how I got here as well. Thank you all.
Thank you, Sarah. That was wonderful. So you briefly mentioned this at the end, but Vicky had a question about copyright. Vicky, feel free to jump in, but do you have any other comments, Sarah, about copyright?
Yeah, I would say it's definitely a challenge. I would try to use resources for pulling illustrations from those ones that I did provide, or finding another resource that has illustrations. If you can't find something that fits what you're trying to do, then a good strategy might be to reach out to somebody who is doing a similar project and seeing where they got their illustrations from. It definitely is a challenge. As somebody who is a scientific illustrator, as long as somebody references either Designs That Sell or our company personally, we don't have a problem with it. So it's just, I guess, being conscious about that and then trying your best to find things that are copyright free. But definitely a challenge.
And I invite everyone else either to unmute yourselves to ask any questions that you have, or I'd be glad to articulate them if you write them in the chat message. So I'll just give it a quick minute to see if any questions come in. The one point I had, so some of the programs that you mentioned can be quite expensive. And one piece of feedback I'd have is to confirm that your institution doesn't have licenses. So you may, in fact, actually have access to some of these programs through being a student or a postdoc or employee of the institution. So if you haven't looked already, you may want to.
Yeah, that's a good point. They also have student pricings, I know, on the Adobe Suite anyway. So for the first year, it's pretty reasonable. After that, it kind of gets a little pricey.
Mm-hmm. Couple more comments. Excellent webinar. Vicky, that answered her question. So if there are no more questions, see, there don't appear to be any questions, and I believe that because it was very well laid out. So Sarah, I just want to thank you very much for participating. It was wonderful. And to those of you who may wish to look at a copy later on, Sarah did agree to share her slides, and we did record this. So we'll be sharing that on our BioCanRx website. And we'll also be sharing it in the newsletter. So if you want to see that, that's where it'll be. So again, and Sarah, I hope you see the comments coming in. Lots of thank yous and amazing. So with that, I'll say goodbye to everyone now and stay tuned with respect to the next webinar that's coming up on May 26th, which will actually be a panel discussion on responding to COVID. So yeah, I'll end there. Thanks, Sarah, and to everyone, have a great day.
Thanks for having me, Megan. It was great.
Bye.